Hello student, welcome back to Install Video Lecture Series for Maths. We believe in democratizing education for all. Today we are going to complete the triangle chapter. Come on, let's get started. So in the previous video, we have understood about the similarity of geometrical figure like squares and all, right? So we have seen an activity also for a quadrilateral. So here we are going to know about the triangle also more in details, and the rectangle and circle and so on. Okay, so first of all, let us learn about the triangle. If suppose you have two triangles and you are going to say that the two triangles are similar if the angles are of the same measure and the side lengths are proportional, then we can conclude that the triangles are similar. Then we can look for a rectangle. So for rectangle, all the angles should be of the same size, that is 90 degree each, and again the side length are again proportional. Then we can conclude that the two rectangles are similar. We have the similarity of triangle. So when we are going to call the two triangles are similar, so to say the two triangles are similar, we are going to check whether the corresponding angles are equal, or you can say that if two triangles are similar, then the corresponding angles are equal. Okay, so if this condition is satisfied, then it's similar. If similar, then this condition is satisfied. So and then we have the corresponding sides are in the same ratio. For equiangular triangle means all the corresponding angles of the same measure, and the ratio of any two corresponding sides are always the same. And for the basic proportionality theorem, which is very important theorem that we are going to learn. So let's see the Thales theorem first, which is known as the basic proportionality theorem, which states that if a line is drawn parallel to one side of a triangle to intersect the other two sides, okay, at distinct point, then the other two sides divided are in the same ratio. It means suppose we are going to draw a line here parallel to the third side. Okay, suppose if we have line like this, if it is parallel, okay, like this, parallel, right? So suppose this is ABC and this is suppose P and Q. So PQ is the line which is drawn parallel to the third side at distinct point P and Q. P is the point for AB side and Q is the point for AC side. Then we are going to prove that AP upon PB is equal to AQ upon QC. Okay, that is nothing but the Thales theorem, which is known as basic proportionality theorem. So we have here given triangle ABC and it's already drawn. Okay, so it will be there. So PQ, okay, as parallel to BC. So to prove, so we have here AP upon PB is equal to AQ upon QC. Now for this, what we are going to do is, we are going to do some construction. So we all know that area of a triangle is nothing but half base into height, the altitude corresponding to the given base. So for this, we are going to draw altitude of the triangles. So here we have one triangle, right? So we will be drawing one altitude here. Suppose this is the base, we will have altitude like this, right? Yes, so this is the altitude to this side, right? Suppose this is now D, right? And again here this side also will construct an altitude, right, which is E. Okay, so we have drawn the peak E perpendicular to this AQ, or we can take it for AC also, right? And then this QD is perpendicular to this. So construction, so we have here QD perpendicular to AB, so this is same as AP also, and then PE perpendicular to AC. Now after this, what we are going to do, we are going to find the area of the triangle. Now here we have area of this triangle using the base and the height will be equal to using this base and the height, okay, that we will write. So we have area of, so this triangle APQ is equal to half. So base is what? Now we are using AP, right? And the height that we are going to use now is QD, okay? Now again we can calculate the area of the same APQ using the other side, okay, means this side, so it will be equal to half, right? And base that we are going to now use is AQ into the height that we are going to use now is this PE. Now here we can see that both the area will be of the same measure, right? Because we are finding the same area. So here we can see that when we calculate the ratio also, right? So both will be equal, right? Now this we have calculated for the upper triangle. Now we can also draw now another triangle by joining like this, right? And then here also, there also we can see another triangle here. So here we can see triangle PBQ and triangle here QCP, right? And now we know that this triangles, right? So when we calculate, it is nothing but base into height again. So that we will be calculating now. So therefore area of this triangle PQB will be equal to half of, so this triangle BP into this height, so QD, and then we have area of the other triangle this side, so we have here PQC, so PQC is equal to half of, now we have now we are taking QC, and then we have the height that is PE, okay? Here let us see why the area of this triangle is half of QD into PB, okay? So this triangle that is QPB can be rotated and it will look like this. Since QP is not perpendicular to BP, now to find the area we need base and height, right? So for the given base, we need the corresponding height. If we consider the base as BP, we need the line which is drawn perpendicular, means 90 degree to this line, right? From the opposite vertex, that is Q. So for that, let us draw a 90 degree, right, from the vertex Q. That will be perpendicular to the extension of the side BP to A, right? So the figure will look like this. Therefore, this becomes QD becomes the height. That is, QD becomes the height which is outside the triangle QPB. So it is not compulsory that the height of a corresponding base, it should be always inside the triangle. It may be outside or inside according to the triangle. Therefore, the area of this triangle QPB is equal to half, base is PB and height is QD. Similarly, we can do it for the triangle PQC also. That will be equal to, the base is taken as QC. Therefore, extension of this base CQ till A will have the height PE, right? Therefore, the area of this triangle PQC is equal to half of this base QC or CQ, both are same, and the height is PE. I hope you got it. Now, this is equation number 1, equation 2, 3 and 4. Now, let's calculate this two ratio. So, the first one, so area of APQ upon area of same APQ will be equal to half. So we have AP into QD, right, which is equal to half AQ into PE, right? So both are same this side on the left hand side, and then this also same, so we can cancel it. So we have here, so 1 is equal to, right, AP into QD, right, and then so we have AQ into now PE. Now which is nothing but, see, we can take it this to the other side, right? Now this can be written as this term, right? Now we can separate this. 1 is equal to AP upon AQ into QD upon PE. Okay, so this means what? They are reciprocal to each other. So now we have the fifth equation. Now after this, to use this equation number 3 and equation number 4, we have to know that these two triangles, this triangle and the other triangle, they have the same area. Why? Because suppose if we are taking this as a base, then we can draw a perpendicular, right? And then similarly this two will be having the same perpendicular, right? So that will be area of a triangle is nothing but half base into height, right? So when we calculate this, we will have base into height. Similarly for this also again base into height, because this line is parallel to this line. So when we draw the height will be of the same length, because height is always 90 degree, right? So here we have two triangles enclosed within the parallel lines, they have the same area. Therefore, these two will be of the same measure. So when we calculate the ratio again here, from this we have area, right? So of PQB, and then the area of this PQC, when we calculate, we will have half will get cancelled, and here we will have that BP upon, right, QC into, right, QD upon this PE, right? So we have equation number 6 and equation number 5. Here we can see that on left hand side both are 1, right? 1 means, and then it means that these two are equal, right? So we can conclude that PAB upon QC into QD upon PE is equal to AP upon AQ into QD upon PE. Now QD upon PE are again and the same term, so we will cancel this, and now we are left with AP upon AQ is equal to BP upon QC. Okay, so we have from 5 and 6. So now we have AP upon, now upon part will have QD, this AQ into this QD upon PE, right, which is equal to BP upon QC multiplied by QD upon PE. So after this we can cancel QD and this part, so we are left with AP upon AQ is equal to BP upon QC. Then we can change it, right? So here we'll change this, so AP upon BP is equal to AQ upon QC. So we can rewrite this as AP upon PB is equal to AQ upon QC. Okay, so this is what we were about to prove, right? AP upon PB is equal to AQ upon QC. Okay, so it's Thales theorem says that if we draw a line passing through the two sides parallel to the third side, then this line divides, okay, the two sides into two parts, right? That parts are having the same ratio. Okay. Next is the converse of this theorem. That is, if a line divides any two sides of a triangle in the same ratio, then the line which is drawn is parallel to the third side. So this is the converse of the Thales theorem, which is basic proportionality theorem. So it says that there is a line, right? So we don't know it is parallel or not. Okay, so suppose if we have a line, if it divides in the same ratio, then it is parallel, it says. So suppose this is PQR and this is AB. So it says that given PQ, triangle PQR is a triangle and the ratio PA upon AQ is equal to PB upon BR, then we are going to prove that to prove this AB line, okay, is parallel to QR line. Yes. So here for this what we are going to do that, let's assume that this is not parallel. Okay, this line is not parallel, so we can draw a line parallel to QR, right? So let's draw a line parallel to QR, okay, passing through A. So suppose we are drawing a line, so it can be below or it can be up, right? So let's draw it. Something like this it will come, right? It may be up or down. Suppose this is the parallel line which is drawn, okay. So suppose this is not parallel, AB is not parallel to, okay, this QR, then what we are going to do, construct, okay, this A, suppose this point is suppose C, right, AC, yes, parallel to QR. So we have drawn AC parallel to QR. Then what we will do? We will apply the basic proportionality theorem now. Okay, so let's apply the basic proportionality theorem. So by basic proportionality theorem, so what we have now, we have that PA, right, upon AQ is equal to PC upon CR, right? Because here we have these two are parallel. AC is parallel to QR. Therefore, let's take this as first ratio, APA upon AQ, right? And the second ratio will be PC upon CR, right? But we know that this is, we know, right? Suppose this is equation 1. So, and then this is equation number 2. So, looking at these two equations, we know that both the left hand side are equal, right? So, from equation 1 and 2, we have left hand side are equal, so right hand side has to be equal. So we have PB upon BR is equal to PC upon CR, right? Now let's add 1 in it. So we have PB upon BR plus 1. Let's add 1. So PC upon CR plus 1. We know that if equal are added to the equals, the answer that we have are equal. So after this, when we do the LCM, we know here that it will be PB plus BR, right? And then we have in the denominator BR. Similarly, here we have PC plus CR upon CR. So we have PB plus BR is nothing but PR, right? And here we have PC plus CR, but this is also PR. So we have here, right? So PR upon BR is equal to, right, PR upon CR, right? So we know that the numerators are equal, right? So we have here 1 upon BR is equal to 1 upon CR. After the cross multiplication, we have CR is equal to BR. So this says that CR length is equal to BR length. It is possible only when B and C are coincide. So it implies B and C are coincide, right? So that means that what we have chosen, it is not parallel, it has to be parallel. Okay, so the ratios are equal, then the line drawn is parallel to the third side. So this is a converse of the basic proportionality theorem. Now next we have, if in two triangles, if the corresponding angles are equal and then their corresponding sides are in the same ratio, then we can say that the two triangles are similar. It means what? Suppose this is a triangle ABC, okay, and then here we have PQR. So that means angles are equal. So angle A is equal to angle P, right? Angle B is equal to angle Q, right? And then we have angle C is equal to angle R. So here in this we have triangle ABC is similar to triangle PQR. So we know that the corresponding sides will have the same ratio, right? Therefore, this AB, since we are taking AB from the first triangle, from the second triangle, it will be PQ. Since AB is the first two letters, so PQ will be from the second triangle. So PQ, which is equal to the next side BC. When we take it from the second triangle, we will take QR, and the third side of the first triangle will be AC, and the third side of the second triangle will be PR. So the corresponding sides are very important in defining this. Next, if the sides, okay, are having the same ratio and then the corresponding angles will be the equal, so then we can say that the two triangles are similar. Okay. So next we have, if one angle of a triangle is equal to one angle of the other triangle and the side including these angles are proportional, then we can say that the two triangles are similar. Means suppose if we are considering this angle and then another triangle is suppose this, then we can rotate this triangle, right? So if we rotate it, we can bring it to this triangle, right? So or without rotation also you can do it. Suppose this angle and this angle, that is this angles are equal, and the side, right, this side containing the angle, that angle as of now we are considering is this, so we will be taking this two side, right? Yes, if suppose the ratios are equal, then we can say that the two triangles are similar. Okay, so next, two triangles are similar, so they have the same shape and they have the different size, and properties that we have is the corresponding angles are equal and the corresponding sides are proportional. So we have seen the condition like AA, there we have seen angles are equal, right? So angles are equal means it's AA. So if you say that two angles are equal in a triangle of different triangle, you can definitely say that all the angles are equal, because we know that in a triangle sum of all the angle is 180. So if you know that two angles are equal, similar, then we can say that the third angle is equal. So in the previous theorem, so we have all the angles are equal, then the sides are of the same ratios that we have learned, right? So that is the AA. Okay, so AA means angles are equal, then we can say that the triangles are similar. Also we have learned about SSS, that is triple S. In triple S it was the second one, the ratios, right, that we define are equal, then angle automatically it will be equal, then we can say that the two triangles are similar. That is the second condition. Third, we have learned just now in the previous slide that if an angle is of one first triangle is equal to the angle of the second triangle and the corresponding sides are of the same ratio, then we can say that the two triangles are similar. That is this part, that is SAS as similarity criteria. Okay, so application of this is we use in trigonometry, okay, we use in scale drawing and indirect measurement technique. So using this, okay, let's see so this is similar or not. So here we can see it. So B, suppose B angle is equal to B1 angle, then A angle is equal to A1 angle. So we have two angles are equal. So what we will use? We use the AA, right? And we can say that the two. So this is one of the example of similarity, right? So if suppose this angle B is equal to angle B1 and angle A is equal to angle A1. So first case where we use AA, right, similar. Now you can use the sides, right, side containing, suppose this and this, suppose if you are defining, so BA ratio, BA, right, then this will be B1A1, right, is equal to BC and then B1C1 and the angle AB is equal to angle B1. So then we use here SAS. Okay, then side also you can take, all the sides ratios are equal, then we can say that the two triangles are similar. Now let's solve few sum based on the what we have learned. So here given triangle PQR, so PQR is the given triangle, and then determine if the two triangles are similar, explain your reasoning and calculate the value of y. So we are going to find the value of y here. Now here it is given that angle P and angle S are equal and angle Q and angle T are equal. Okay, so we will consider two triangle here now. So in triangle, okay, PQR and triangle, okay, STR. So what do you know from here? We know that angle P, right, that is angle QPR is equal to angle, right, we have TSR because it is given that it is equal. Okay, see here one angle symbol, one angle, it represents these two are equal, here double represent these two are equal particularly. Okay, so we have next this Q and this are equal, so PQR is equal to STR. So by AA similarity criteria, so we have these two triangles are similar. So triangle PQR is similar to, this is a symbol for similarity, so triangle STR. So both are similar means what? The corresponding sides will have the same ratio. So from this we can conclude that PQ, right, upon ST is equal to QR upon TR, which is equal to PR upon SR. Now here we know that this PR is nothing but PS plus SR, right? So we can write this as 11 plus Y, and we have this QR is 16 plus 14, right? So we will be writing that. So we have 11 plus Y, right? So this is the value of PR, right, upon Y, right, which is equal to 16 plus 14 upon 14, right? Because before we know that this is QR, right, QR upon TR is equal to PR upon SR. So PR value is 11 plus Y and then SR is what? Y. So 11 plus Y upon Y is equal to QR is 16 plus 14 upon 14. Okay, so After this calculation, we have 11 plus y upon y is equal to, this is 30 upon 14. So we can cancel it and we have cross multiplication. So this is 15 upon 7. So 77 and plus 7y is equal to 15y. So this is equal to 77, which is equal to 15y minus 7y. Right, so that is 77 is equal to 8y. So the value of y is nothing but 77 upon 8. Okay, so this is how we calculate the length by using the similarity criteria. So here in this question, it is given that these two triangles are similar, so we are going to calculate the unknown angle x value, that is angle P. So it is given that triangle ABC is similar to triangle QPR. It means the corresponding angles are equal. That is, angle A is equal to angle Q, angle B is equal to angle P, and angle C is equal to angle R. So if we calculate the value of angle B in this triangle, then it will be same as this unknown angle. So we know that in a triangle, the sum of all the angle is 180 degree. Therefore, in triangle ABC, so angle B is equal to 180 minus 43 plus 76. So which is equal to 180 minus 119, which is equal to 61 degree. So that is nothing but angle P, the value of x. Okay, so the value of this x is nothing but angle P, which is 61 degree. So like this, we can apply the similarity of triangle to find the unknown angle, as well as for side we have learned in the previous slide. So let's recap what we have learned in this entire chapter. In this chapter, we have learned about the triangle and its type, so properties of the triangle. Also, we have discussed about the quadrilaterals, similarity of quadrilaterals, and the congruent triangles. We have learned certain criteria for congruence of triangle. Also, we have learned about the similarity of triangle, and not only this, we have learned about the basic proportionality theorems and the converse of it. Also, we have seen the application of it. So I hope you have thoroughly understood the chapter triangle. So keep watching our install video. Thank you.